I got a 2006 Toyota 4Runner. This is the truck that had the bad alternator right out the box from AutoZone, and got another one and it worked perfectly fine. I think I got it from O'Reilly's or somewhere. Anyway, it's back again and it has a misfire. The coil was on cylinder 6 and wound up moving it over. And I just took the basic route initially, just swapped the coil, found out what it was. But the video is primarily about if you do have the Autel maxiscope. This joker here, I forgot the part number. It's somewhere on there. But if you have the Autel maxiscope, it's not going to be as detailed as a Pico, from what I understand. So hopefully this helps out. I'm gonna try to give you a brief synopsis of how I got things hooked up. I do have an amp clamp. Let me go over that first. The amp clamp I do have on my channel A. I'm on the small scale, the 20 amp scale. I'm gonna show you how I got that hooked up. Let's turn this off. So let me show you that. So I got some leads here that goes into the fuse. That fuse actually, that's the IGN fuse, the ignition fuse, the 10 amp. You can see that. So that fuse actually controls the fuel injectors that supply power there. I'm on the small scale. It supplies power to the fuel injectors and to the ignition coil. So one thing you will notice with this waveform is that there's like additional humps in between the firing sequence. So these right here are likely going to be our injectors. Let me show you what I got. We move over to my ignition coils, and again I changed number 3 here. This is at number 6. So we're on bank 1. Bank 1 is going to be on the passenger side here. Bank 2 is going to be on the driver's side. So here's our coil number 135. Here's the bad one. I'm hooked up on the signal side here, and this looks like it's a green and blue wire. It's like it's a green wire. I'm hooked up on that. Here on coil 1, I'm hooked up on the signal, and I'm hooked up on the IGF, ignition confirmation. So the black and the red is our power wire. The white and the red is going to be the IGF wire. This yellow wire on coil 1 is going to be my signal. Black and white is going to be the ground. These grounds also are utilized. They're like a monolith, I guess. They merge into a single ground. You'll see that on the wiring diagram. And like I say, also I'm gonna start putting wiring diagrams at the end of the video or either between them, so it'll help anybody else out. So I'll put that put that note in the front. So today I just wanted to show you that despite having a amp clamp and a little bit of technology added on to your ignition sequence or the components, you got to just be vigilant about using the low pass filter, because it could mess up how you assess things. But I just want to show you, this is our green. This is number 1. This is a working side here. This is what I just used for my reference. And so here, our green, that's the signal side. The blue is the IGF side. That's the ignition confirmation. So basically what goes in gets sent back out and goes back to the PCM to ensure that, hey, I'm working. And I'm going to show you that shortly, what that looks like. So again, the green is the signal side to coil 1. Since that's working, that's our reference. Blue is going to be the IGF, the confirmation, and our amp clamp is going to be channel A. That's the orange here. So what's going on, if you notice on the good one here, it's graduated. The coil get turned on to activate, and then the amps start to graduate till it maxes out around 8 amps. Coil fires, and then the amps descend. Let's see if I can show you like an injector. So this is one. I want to see if I can get them all here. If I can get, there's one again. So 1, 2, 3, 4, 5, 6, and then there's one again because there's our green trace. And then you can, like I said, you can see between here, these are injectors. Like I said, the fuse is tied in with the fuel injectors also. So if you have no power going to the coils, you want to check that fuse. If you have no power going to the coils and the fuel injectors, check that. These are like a sequential fire, if I recall, because they all single wires go to the computer system. Sorry, I digress. So here's the bad one. I don't have a low pass filter on this one, but if you notice on here, it doesn't graduate. It just spikes up. Let me see if I can pull that down there. I might have to start it over again. Let me see. Let's go here, pull it down. See how it just jumps up. Let's go back to number 1. And then you will see how number 1 just gradually ascends up. There's number 1 right there. Just that little bit, that little small detail right there. So assuming that you don't, you just want to play around, look at that gap. And just diagnose it without having to use your scan tool. I mean, this is something just to be vigilant on. Go back down again. You can see how it just spikes up. So that's like the spark getting consolidated, like it's shorting out or something. But it's not like, it don't seem like it's fully shorting out. It just seemed like it just hit a brick wall. Where it's just like the coil attempts to work, but the spark just doesn't get sent down to the secondary. That's what it looks like. So here's some of the other cylinders here. So this is 3. Look at 4. It gradually ascends. 5. Gradually ascends up, and 6 gradually ascends up. That's the one the coil eye wound up changing. Oh shoot, where did it go? See if I can get it right there. And then we're just gonna go right back to 1. Now they're making, let me go back, let me see if I can zoom out. They're making the same amperage. Let me drag it down here. That down there. I can get a ruler. I'm zooming out. So that's 1. I want to get this out of the way here. I mean, you can see that there's a spike there, but that's just potentially noise. Here's our bad one. There's our good one. I mean, it's not much of a difference there, but for the simple fact that it just spikes up and it doesn't graduate like 1 and 2. So let me put a low pass filter on here and show you that there's a difference. All right, I'm gonna leave that right there. We're gonna start it up. I'm gonna put the low pass filter on there, and we're gonna look at the same thing and show you that there's a difference. Here we go. So if you notice here, everything is like wavy, like you don't see the spike. So you imagine like, oh, okay, this is fine. Move on to the bad cylinder. Oh, this is fine too. I mean, sometimes you get those little frets up there. It's like some radio frequency noise. And a lot of times I don't let that bother me. Because I mean, it can happen. Yeah, that can happen also. So sometimes it could mean something, but usually, I mean, I've had that happen on like crank sensors, and it doesn't mean anything. And it's like sometimes what you got, the other signals can interfere with that and generate that. So here before it was just flat and it just spiked up. Now it's just a wave. And naturally, I guess I would imagine a person would assume that, okay, it's fine. We have a ramp, a current ramp. We could take a measurement. I know it's like sometime it'll do it. Gosh darn it. Well, you can get the idea. Let me just bring it up to the IGF. That's pretty linear. Yeah, about the same height right there. They're like literally the same height. So it's something that's definitely just easily look over. So one other thing I want to show you, you can pull, let me go back here. I'm going to have to start this over. So the IGF is the blue trace there. So despite this coil being bad, it still shows that there's signal there. Vehicle utilizes like a lot of other things to determine a misfire. I'm not going to go in great detail about that, but just because you have a IGF signal could cause you to also overlook that. So just be vigilant on that. I'm going to disconnect this, and being that we know we got a signal here, I'm going to show you how it looks if there's actually some discrepancies going inside. We got a signal coming in, but it's not being, what we got? Okay, that's just some noise. I'm gonna start up, but if we got some signal coming in, but the voltage value is not getting dissipated and generating a square wave, it should get dissipated inside the lead there and just look different. That's something I noticed. Let me start it back up. Take off my low pass filter. So assuming that you potentially have some issues with the inputs, you can see our IGF is gone now. Look at that. So we still have, like, this is our reference of working system number 1. We have our signal, we have our IGF, and we have a ramp for our amps, 2. And then here's 3. We have a signal attempted to come in, but it's not doing anything. And it's like the voltages pretty much get dissipated in our lead there and just gradually ascends. The IGF wire, that's gone also. Let me show you. So there's 1, 2, 3, would be 3, 4, 5, 6. Start back over to 1. So coils can like break in so many different ways. So just testing just the IGF wire isn't that conclusive. Testing the signal really is inclusive, but you should have to. Don't get me wrong. Still test them, but just to make note of this. All right, let me put the new coil in there and show you the difference. We're still hooked up on 3 here. All right, the coil I'll be using is an import direct. It looks same as this aftermarket coil. Hell, for all I know, they probably came from the same warehouse. Who knows? They look exactly the same. Smells a little burnt too. Import direct got a part number on here. This other one doesn't. I'm gonna put a little bit of dielectric grease in there just to make life a lot easier whenever it has to come back out. Hopefully not for the same reason. If you've been looking at some of my other videos, you know that I'm kind of like, I have mixed feelings with import direct, especially from like the water pumps and stuff. But the coils work okay, so I give them credit. Let me get that tightened up. Alright, we're back started. Got the new coil in there. Got the low pass filter off. And we're just going to observe the number 3 coil again and see if there's any difference. So we should have enough information right there. Let's zoom in. There's 1, 2, 3. So look at it now. It graduates just as all the other coils. It's number 1. Number 2. Number 3. It's a bit of drag down now. Nope. What the hell is it? I don't know why. It's like sometimey. I'll break my neck over it. But they're all like the same height. I'm going to use this IGF as my straight edge. So it's like the same size as all the factory coils. I want to show you one other thing I noted. I got the trace for, which one was it? The purple. That's on my ground now. I'm going to show you something that I just noticed before. With the old defective coil, there wasn't any ground being pulled, so you didn't see any spike or anything. You just saw nothing. I'm gonna see if that shows it now with the good coil, and I might just have to throw the old one back in there to show you what I'm referring to. Show you the ground here on the working one. Now I can understand why it's higher than 2 and 1 because I'm hooked directly up to it. But I mean, it could mean something. I mean, I would have to literally hook up on like 1 or something to see if the ground changes, making it more pronounced. But I'm likely going to put the old one back in there just to show you what I was referring to, because I didn't do it with the old one back in there. But there was a difference with the ground. It didn't have any spike or any type of exaggerated lines, I guess, in relation to the spark being dispensed. That make any sense? So I guess because the spark wasn't being sent out, there was no need for the voltage to travel anywhere else. So I did notice that with the old one. I think I got a screenshot of that. I took a screenshot of a bunch of stuff. I just hope I had the same time base. Let's go down here. I want to say it was this one right here. So this was the ground on the green. This was the old one. and before I started moving some stuff around, it just didn't have that exaggerated spike. And I mean, it was just something I just noticed. I mean, and it was pretty consistent. That's why I went on here and took a screenshot. So it might be something worth looking into. Hopefully some of this information was a little useful when it comes to just assessing some of the stuff with Autel, especially if you got an amp clamp, because I mean, from what I understand, it's not as detailed as like some of the other better quality oscilloscopes out there. But I don't have those, but this is just something I just noticed with this, and I would hate for somebody else to get all frustrated and stuff and be like, just fuck Autel. Autel is not that bad. They have their problems, and I got a couple scan tubes that are door stops, the expensive door stops. But I mean, they for what you pay, can we complain? In regards to this misfire, the system is very simple. It's not nothing complex. You still have to, it's just a 4-wire system. You got the power, 12-volt power supply. I showed you that. You have a ground supply. I want to show you that in the very end of the wiring diagram. You have a signal, the square wave coming in. We saw that. That's this, like this green trace here. It's a square wave. It tells the component, the coil, to start to perform in charge. And we have the output confirming that it does get a signal going in and going out, which was the IGF wire, the ignition confirmation, which is this blue one right here that we pulled up, that blue joker. So we saw the signal, saw a current ramp, and we saw some output going back to the PCM, being that they're all interconnected with that one system there to confirm that the computer, hey, is working, is signal going in, signal going back out. So as far as like misfires, I wouldn't be able to specifically tell you exactly what creates this. And being that it doesn't have the same velocity going back down, I assume that's what generates a misfire. Don't know. I can only speculate. But if anything happened, I'll definitely update. Hopefully this coil works like it's supposed to. Some of y'all know that I've been having some issues with import direct. Not with electrical stuff, but the water pumps and mechanical. But that car does have a lot of issues. The Toyota was a Toyota Corolla, Camrys and stuff. Now, the only issues I know right out the box I've had some electrical issues with was WVE. Or if you bought it from Rock Auto, I think O'Reilly sells a WVE product. I want to say, don't hold me on that. I want to say they do. In rare cases, right out the box, that joker didn't work on several different instances. Crazy. But we should be fine with this import direct. I'm gonna wrap this up. But hopefully, if you have any questions, I'll try to answer them to the best of my ability. Really not the smartest person when it comes to oscilloscopes, but this is just something I noticed. But if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed, had a rich of my work. See you next one.